we're starting with what is an exponent. An exponent, remember, is just a way to simplify how we write things. So when we write something like this, remember that the big number is called the base, right? And then this is called the power or the exponent. So this is the power or the exponent. And you've been doing these, I don't know, for a while, at least since junior high school, that you were shown exponents. That 2 to the 4th power does not mean 2 times 4. It means 2 times itself 4 times, right? It tells you how many times the base is multiplying by itself. So this is the same as saying 2 times 2 times 2 times 2. You know that problem right now. The big thing I want to go through with you today are the rules of exponents. Before we start looking at fractional exponents and taking like the 4th root and the 5th root of stuff, I want to remind you about when do you add exponents, when do you multiply exponents, stuff like that. So that's what today is. Everybody okay with that? So I kind of wrote this and then I wrote it in words. If you're okay with just the formula, you don't have to write this part out. This is called the same base product rule. If you have the same base and you're multiplying them, do you remember what you do with those exponents? You add them. A to the x times a to the y is the same as saying a to the x plus y. And if you don't want to write this part out, which I'm fine with, just write these little examples out. Should give you some real number examples. But the rule says when you multiply terms whose bases are the same, you keep the base the same, and you add the exponent. This is what the little fill in the blank there is. And so on today's homework, they're not going to be as simple as this. We're going to do some ones like your homework in a minute. But if you see x to the 3rd times x to the 4th, that means there's 3 x's and 4 x's, so that means that there are just 7, or x to the 7th. The mistake that people make is often with numbers. They do well with this, but for some reason people want to tell me that this is 9 to the 12th power, right? No, it's not 9 to the 12th power. There are 5 3's and 7 3's. So that's why there are 12 3's. You keep the base the same and you add the exponents. I could keep going here, but I feel like that's, you get that? Add the exponents. These might be my notes from ECA lab. That's why they're like words and then this part too, but that's okay. I'm not going to do that one if you're okay with that. How about the bottom one? Look at this one that's on here. You don't have to write this down. What if you had muffin to the 6th power times muffin to the 8th power? You have muffin to the 14th power. Okay, moving on. That's a lot of muffins. We also have the quotient rule of exponents. And you've probably already been doing this. We've been simplifying rational expressions. But remember, if the bases are the same, then what can you do with those exponents? Subtract them. So a to the x divided by a to the y is a to the x minus y. And again, you don't have to write these words unless you just really like words. Subtract the exponents. A lot of times I think of canceling out more than subtracting, especially when you get into negative exponents. I feel like canceling out works out better, but subtraction always works as well. So I put a few examples here, like 3 to the 11th over 3 to the 6th. You could just cancel out 6 on the top and 6 on the bottom, or 11 minus 6 gives you 3 to the 5th left over. Again, notice the base stays the same, you subtract the exponents. We could even do one with all letters. W to the R over W to the V is W to the R minus V. You would just write it like that. Okay with that? All right, moving on. I kind of put a few other ones on here, just some other exponent rules to remind you of. Remember that the 0 power any number to the 0 power is always what? So I just wrote 8 to the 0. Any number to the 0 power is 1. You don't have to write that either in the sentence part. A few other rules I wanted to put on here. Exponent to exponent rule. If you have a power to a power right next to each other, you remember what you do to that? You multiply. So the big thing is you got to remember when to add your exponents, when to multiply your exponents. And what we're going to do in a minute, I have one more page of rules, and then we're just going to kind of put all these rules together into one problem. That's not easy. Only these rules are.
So did you like make better calculators?
Yeah, well I did. I want to do the least amount of work possible, just like you. So if I've already done these rules at one point, I just like, let's just copy paste. I'd still teach you. I still have to do it. Right? These are my last rules. Yeah, I bet you learn a lot. Three more rules here. Product or quotient to an exponent. I always say this is kind of like distributing the exponent, but not really. But if you have something multiplied, not added, multiplied in the exponent on the outside, you have to give that exponent to everything on the inside, right? And the same thing is true for a quotient. That if you have a quotient all to a power, you have to give that exponent to everything on the inside. And then the last one is negative exponents. Remember that negative exponents are not negative numbers. It's actually like the reciprocal of a number, right? And so I always teach my kids when I teach them in Algebra 1 and even in Algebra 2 that the negative is kind of like the ticket to move across the fraction bar. So if you have a negative exponent, you get to move to the bottom of the fraction and turn in your ticket, which is turning in your negative sign. If you don't have a ticket, you don't get to move. And so if I move that to the bottom, then now there's just a 1 left on top, and that's just the reciprocal of that number.
But if it's on the bottom already, it's negative.
You move it to the top. So yes, so if it has a negative exponent, it moves to the opposite position in the fraction. Okay? We don't like to leave our answers with negative exponents, so we always want to simplify them. So let's do a couple examples here. And your homework probably, maybe, won't be so bad today. So if you don't have yesterday's done, you can still go back and finish it. So here we go. We'll kind of work our way into this. You really should be able to do these without a calculator. And the beginning part of your homework is just like number 1 here. They actually just give you numbers with powers, which I know your calculator can do it. I want to know that you're practicing the properties here. When we have a power to a power, what do we do with those exponents? Multiply. So negative 2 times negative 1 is really just positive 2, right? So we could say that that's just 9.
So you want us to make it 9.
I don't care. If you leave it like this, it tells me to use calculator, so I'm okay with that. So it doesn't matter. Yeah, I don't think they're any to the 10th power, but I think they're all pretty small. This is more like what's on your homework today, like X's and Y's, numbers in front of there, where they want you to simplify, deal with your negative exponents. The big thing on this is there's more than one way to do this problem. As long as you aren't breaking any rules, you're going to get the right answer. I'm going to show you the way that I like to do it, and then you can, do your own way if you want. I don't like negative exponents, so I like to move them first. You don't have to do that, though, because you could just subtract your exponents and deal with it. But for me, if I see a negative exponent, I'm going to turn in the ticket. So since this one's negative, I'm going to move it to the bottom. You agree with me on that? It's the only one that has a ticket, so it has the only one that gets to move places. Everything else is going to stay in the same spot. Again, you don't have to do that to get the right answer, but I feel like it saves you trouble of messing up negatives. Well, yes, on the bottom, right? So Nathan says on the bottom, this is y to the first and y to the second, and when you multiply, we add those exponents, so he says we get y to the third on the bottom. And what about x to the fifth over x to the third? Yeah, 5 minus 3 is 2, so that would be on the top, or if you want to think about it, you could cross out 3 of those x's, and you'd have x squared left up there, right? Like the whole canceling out. And that's your answer. Isn't that a little better than yesterday somewhere? We're working our way into this. Let's try another one. What about this one? So it's a big parenthesis there, x to the negative 3 over 3y to the negative 1, all to the negative 2. And when you're doing these problems, it's very similar to like if you were doing order of operations. You want to start with the outside first. So when I see this big negative 2 out here, I guess it's a small negative 2, but when I see the whole thing is to the negative 2 power, I think that's where you should start first. And remember, if everything's to the negative 2 power, you need to give that negative 2 to everything, right? We're going to multiply those exponents. So that's my first step I would do in this one. So negative 2 times negative 3 would be positive 6. Don't forget to give that to the 3. That's what people forget to do a lot of times. They give it to all the letters, but they forget that that's 3 to the first power right now. So if I give that to the negative 2, that would be 3 to the negative 2. And y to the second. Everybody with me on that? What else could I do? Yeah, we don't like negative exponents, so can I just move that up and make it a positive exponent? And this is where I probably would write 9 and not 3 squared, but I'm going to leave it like that for a second. Okay. It's its actual number. So that would be 9x to the 6th over y squared. I can't do anything with these because they're not the same letter. That's it. That's your answer. How do you feel about that? So it's kind of just a review. Let's see if I have one more. I don't remember. Oh, that's it.
Man.
Darn. I didn't even write the homework out. Page 70. I don't know if that's right or not. Today, what is today? Today's Tuesday, right? Page 27. Because before we do R8, we're doing this little review from R2. So this is page 27. You're going to do 74 through 84 even. And 85 through 94 all. You look at them, you'll see they're not so bad. I'm gonna get out of here. Like 40 something, 42. So 74 through 84, those are just numbers. Like 74 says negative 4 squared. So I'm trusting the learners about it. But then 85 through 94, those are like the ones we just did where you have to simplify the x's and y's and the negative exponents. We'll talk about that tomorrow, and then tomorrow we're going to do simplifying radicals, not just square roots, but like cube roots and fourth roots and fifth roots, adding radicals, multiplying radicals, stuff like that. Is the plan. So make sure you're